Okay, so we have here today a really interesting looking integral from the UNSW Integration Bee 2020. This was C2. We have the integral from -1 to 1, the sum from 0 to 9 of k x to the k dx. Okay, now it's always a little troubling when we have a sum involved with an integral, but we just really need to break it down. This is not that hard, because we can just kind of expand this out. And I think that's what I'm going to do, is just rewrite it and kind of expand it. So we're integrating from -1 to 1. The first term, we really don't need to start this series at 0, because if you plug a 0 in here, that's just 0. So I can actually just change this to 1, and we can start at 1. And then we can just start writing down terms. So like plugging in 1 here, we have 1, x to the 1, that's just x. Then we have 2, x squared. Then when our k is 3, we're going to have 3, x cubed. And this is going to go all the way to our last term, which is just 9, x to the 9th dx. So when we write it out this way, we see that it's really not a big deal. It's just this big polynomial, right? It's just 9 terms. And of course, we could just do power rule on this and finish off, but it's a little tedious because we got 9 terms. So hopefully we can get a little simplification. But what I want to notice is we do have symmetric bounds around 0. So what I want to do for this is use the concept of even and odd functions for this. Okay, so we have these two concepts over here to the right that we're going to use. So first, if we have a function f of x, and f of x is odd, and we're just integrating that function with symmetric bounds, the integral is just 0. And so notice that we have a bunch of odd functions. If we split this up into 9 integrals, I'm not going to do it out formally, because you can see this can be split into 9 integrals. But we have a bunch of odd functions. 3x cubed is odd, 9x to the 9th is odd. Everything with an odd exponent is going to be odd. So each of those split out separately with symmetric bounds, those are all going to be 0. So I'm just going to cross that off, cross that off, cross that off. The 5th term and the 7th term, those are going away, and we're just left with our even terms, okay? But now with every other term even, this whole thing is an even function now. So then we come to our second case here. If g of x is even, and we have symmetric bounds, then we can just pull a 2 out and reduce the lower bound to 0. So we'll use this principle, and we'll bring a 2 out front here. We can change the lower bound to a 0, upper bound will still be 1. And then we're going to have this even function, but now I'm just going to write it all out because there's not that many terms we're going to have. So just writing out the even terms, we'll have 2x squared, 4x to the 4th, 6x to the 6th, and 8x to the 8th dx. But now at this point, I will use power rule just to finish this off. So we'll have our 2 out front here. This first term is going to become 2/3 x cubed. We're going to have 4/5 x to the 5th, 6/7 x to the 7, and this is going to be 8/9 x to the 9, and we just need to evaluate from 0 to 1. But now when you evaluate this at 0, everything's 0, so we don't need to worry about that. We just need to evaluate at 1. But then evaluating at 1, all these terms like 1 cubed, 1 to the 5th, 1 to the 9th, those are all just 1. So we can just kind of get rid of all this, and we just need to combine some fractions. But now this part is a little tedious. Let me just do this out really quick. I'm going to actually factor a 2 out of all this stuff because we have all this even business. So I'm going to write this as 4 times 1/3, 2/5, 3/7, 4/9. And I'm kind of out of space. Let me clean up the board, just finish this off. Okay, so let's just do some quick arithmetic here. Now 1/3 I'm going to write as 3/9, so I can simplify it with this. And putting that together, that term's going to become 7/9. So let me copy down the rest of this business. But then here I think I need to get a common denominator. 9 times 7 is 63, times 5 is 315. So we're going to put this all over 315. So let's see what we have. We do this, we'll have everything over 315. Then let's see, 63 times 2 is 126. 5 times 9, 45, times 3 is 135. 5 times 7 is 35, times 7 is 235. No, 245. 135 plus 245 is 380, plus 126 is 506 over 315. 4 times 506, this gives me 2,024 over 315. Okay, so weird problem. It wasn't too hard, just kind of like some tedious arithmetic at the end. I think they wanted to see if you could just do it in time. So, okay, that's it for today. Thanks everyone for watching. Have a good day.